Now we are discussing about a stable multivibrator using 555 IC. We already discussed a stable multivibrator using op-amp. Here we are trying to discuss about the stable multivibrator by using the 555 IC. A stable multivibrator is also called as a free-running multivibrator. In this multivibrator, there is no stable state. The output switches from one state to other state continuously. Here you observe, we have connected the circuit like this. In this circuit, initially we are assuming that the voltage across the capacitor is less than VCC by 3. Because the voltage is less than VCC by 3, the voltage of this is second comparator, this is first comparator, or this is upper comparator, this is lower comparator. In lower comparator, the voltage at the inverting terminal is less than the voltage at the non-inverting terminal. So the output is high. Because the output is high, at the set pin, the value is 1. At the set pin, value is 1. So Q is 1, output is 1. In the SR flip-flop, when we give both zeros, then the output will be no change state. When the input is 1 to the reset pin, output is 0. When the input is high at the set pin, output is high. When both are high, that is forbidden state. That state we will not use. Here Q is 1. Q is 1 means obviously Q bar is 0. So Q bar is 0. At the base of the transistor, we are not providing any supply. Now the transistor is in off state. Because the transistor is in off state, this capacitor still continues charging. And it continues charging when the voltage across the capacitor crosses the 1/3 VCC. Now here the voltage is greater than 1/3 VCC because the capacitor is charging continuously. Now the capacitor voltage crossed 1/3 VCC. So the output will be, so the capacitor voltage crossed greater than 1/3 VCC because it is charging continuously. And the voltage at the inverting terminal crossed the voltage at the non-inverting terminal. So the output becomes low. Because the voltage at a negative or non-inverting terminal crossed the non-inverting terminal. So the output becomes 0. At this set pin of this flip-flop, the output is 0. Now the reset pin is getting the 0 and set pin also getting the 0. When we are having 0, 0, then output will be no change state. So the output remains at 1 only, even though the state of the S is changing from 1 to 0, the output remains 1. Still the capacitor continues charging because still the transistor is in off state. Still the capacitor is charging and its voltage crosses not only 1/3 VCC and its voltage reaches to 2/3 VCC. To the same capacitor, we have connected the threshold pin. To the same capacitor, we have connected the positive terminal or non-inverting terminal of the upper comparator. So when the capacitor voltage crosses the 2/3 VCC, at that time, at the negative terminal of the upper comparator, we have the voltage 2/3 VCC. But now capacitor value crossed the 2/3 VCC. So the upper comparator output will be high. Because the upper comparator output is high, it is activating the reset. So now the SR flip-flop inputs are, we are giving 1 to R and 0 to S. Because of this, the output will be 0 and Q bar becomes 1. When the capacitor value is reaching to 2/3 VCC. Because the Q bar is 1, we are providing the supply to the base of the transistor. Then this transistor acts like a closed switch. This capacitor finds a path for the discharging. Now this capacitor C1 discharges using the resistor R2 and in this path. So this is the path capacitor is discharging. R2 and this transistor. The capacitor starts discharging. Because the capacitor starts discharging, the voltage across the capacitor, which was greater than 2/3 VCC, it decreases to less than 2/3 VCC. Now the voltage is less than 2/3 VCC. Even though the voltage is less than 2/3 VCC, definitely the comparator value changes to 0, but still the output remains in the same state because the R input and S input both are zeros. That's why the output remains in the no change state and the output remains in the same state. Now, the transistor, through this transistor, the capacitor discharging continuously. When the capacitor discharges its value, now the value it reaches to 1/3 VCC. At that time, immediately, when its value is reaching to 1/3 VCC, immediately the comparator value, because this value is less than, this negative value is less than 1/3 VCC, but the positive value is fixed at 1/3 VCC. So the capacitor discharged to 1/3 VCC. Now the positive value is higher, that's why it will be high. Because it is high, the set pin is high, again the Q changes to 1 and Q bar changes to 0 and again the transistor turns off. Now it acts like a open switch. Now the transistor turns off. As the transistor turned off, capacitor stops discharging, immediately it starts charging. It charges by using this VCC R1 and R2. It uses this path for the charging. And it charges in such a way that the capacitor charges, its value crosses greater than 1/3 VCC. And when its value crosses the 1/3 VCC, at that time, when its value crosses the 1/3 VCC, at that time, the output of this comparator will become 0. And when the output of the comparator becomes 0, at that time, the set pin is 0. That's why Q will be 0 and Q bar is 1. So actually, because it is 0, when the reset pin is 1, then only it becomes 0. Because it is 0, it remains in the previous state as usual. The previous state is 1 and 0, it remains in the previous state as usual. Now we discuss the same concept with respect to the waveforms. See here, when the capacitor voltage is crossing the 1/3 VCC, at that time the input is becoming high. At that time the input is becoming high. And when the capacitor voltage reaches the 2/3 VCC, immediately the input is falling to, the output is high. And when the capacitor voltage crosses the 2/3 VCC, the output is falling to 0. And again, when the capacitor starts charging from 1/3 VCC to 2/3 VCC, the capacitor, then the output will be 1. So the output will be oscillating between the states 0 and 1. The output is continuously oscillating between the states 0 and 1. When the output is 0, and when the output is 1. These are the two states we are discussing. When the output becomes 1, when the capacitor is charging. When the output becomes 0, when the capacitor is discharging. It is simple. It is high when the capacitor is charging, and it is low when the capacitor is discharging. So this time the capacitor is charging because of the two resistors R1 and R2. You see here, this is R1 and this is R2. నేను మూవ్ అవుతుంటే దానికి తగ్గట్టుగా మెల్లగా మూవ్ చేయాలి. ఓకే, స్టార్ట్ చేస్తావా? మరి స్టార్ట్ చేస్తే ఇదంతా రికార్డ్ అవుతుంది కదా, ఆఫ్ చేసి మళ్ళీ ఆన్ చేయాలి నువ్వు. Now when the capacitor is charging, the output is high, and when the capacitor is discharging, the output is low. When the capacitor is charging, it charges because of the two resistors R1 and R2. You see here, the capacitor is charging because of the two resistors R1 and R2. It charges by using VCC R1 and R2. When the capacitor is charging because of the two resistors R1 and R2, but when the capacitor is discharging, it takes the R2 and the transistor path. Capacitor will not discharge through the R2 path, but capacitor charges with the R1 and R2. R1 is used for charging, R1 and R2, but for discharging only R2 and the transistor. Okay, now you see here, when the capacitor is charging, the output is high. What is the time it will retain in this state? How much time it will be in this state? Then T1 is equal to 0.693 R1 plus R2 into C1. R1 plus R2 into C1. And T2 is the off state. And how much time it remains in this off state? 0.693 into R2 into C1. Why only off state depending on the R2? Because the capacitor is discharging through R2 and the transistor path. Why the charging is depending upon R1 and R2? Because the capacitor is charging through VCC and R1 and R2. But the capacitor is same, C1. But the time constant why we are using two resistors means for charging the capacitor deciding this path, R1 plus R2. It is charging by using both resistors R1 and R2. But for the discharging, it is selecting the R2 and the transistor path. So the total time period is 0.693 into R1 plus R2 plus R2. So R1 plus 2R2 into C1. That's how we can control how much time this should be in high state and this should be in low state by using the resistor values. The resistor values are deciding the time period T1 and T2. Also definitely the capacitor value also deciding, but we are maintaining the same capacitance value for the on and off periods. Off period is completely depending upon the R2 only. On period is completely depending upon R1 and R2. Here, where we use this circuit? We use this circuit in pulse width modulation, in pulse position modulation, in security alarms, in analog and digital converters. In all these circuits we use this. We are now seeing the pin diagram. So here we have just connected the 555 IC pin. First pin is ground pin. Fifth pin is control pin. So instead of 2/3 VCC, 1/3 VCC, by using the control voltage we can control. So this control pin is connected to the capacitor 0.01 microfarad capacitor. And the second pin already we have discussed about the trigger pin, and sixth pin is threshold pin. Both pins we are connecting to the capacitor. And these are the R2 and R1. We are always connecting the seventh pin we have connected to R2. And we are connecting the fourth pin, master reset pin, always to the supply, because when it becomes low, then the entire 555 IC will be reset. Here we are trying to explain the operation. when the voltage at the capacitor it is greater than 1 by third VCC, then the output of the 555 IC, the output will, here we are getting the output. The output of the 555 IC we are getting high state. And when it reaches to 2 by third VCC, immediately its output becomes low. Again, the capacitor starts discharging through this path, through R2 only. So definitely, when the capacitor starts discharging, again it reaches to high state when its value is crossing the 1 by third. When it is charging, again it starts charging. So during the charging time of the capacitor, it will be in high state, and during the discharging time of the capacitor, it will be in the low state. This is how a stable multivibrator using the 555 IC circuit can be operating.